Welcome to the DD1324 online lectures. In this lesson, we will cover flow control and loops. We'll begin with the if conditional statement. In the basic syntax of the if conditional statement, we start with the keyword if followed by parentheses, which contains a logical expression. If that logical expression is true or non-zero, then control passes to statement 1, which is enclosed in parentheses. This is the only required part of the syntax. Beyond that, you have several other forms of the statement, including else, if, and else, which are completely optional. If the logical expression contained within the if statement is not true, then control passes to an optional else if statement, which can add another condition if the first one is not met. If this condition is met, then control passes to statement 2. You can continue with several else if statements until finally you can end with an optional else statement. Notice that the syntax for each of these conditions requires that you have curly braces that contain the statements for if each of the conditions is met. That includes the if statement, the else if statement, and the else statement. There is another form of the if conditional statement that ignores the curly braces, but this is a specific case where the statement that follows the if statement or the else statement uses exactly only one line. Then the braces can be omitted. So let's look at a simple example of some code with an if statement. First, we'll include stdio.h, and now we'll make the main function, open and close parentheses, return 0. And now let's make a variable an integer 1 and make it equal to 1, and another an integer 2 and make it equal to 2. Now we can begin with the if statements. First we'll make the if keyword, and inside of these parentheses we'll put a conditional statement. So we'll say 1 minus 1. So this should have a logical evaluation, and if that's true, then we'll say printf, the first condition is true. And if not, we can have an else if, and we can test another specific condition. Let's say if 2 is equal to minus 1. And we can put another printf. The second condition is true. And finally, we can make an else to catch anything that didn't make the first two. And we can have a printf. None of the above statements are true. Okay, so we can save this, and then we can compile it. And then we can try running it. And we can see that it says none of the above statements are true. And we can go back and look at the code and see why. In the first one, we have 1 minus 1 is 0, so that's false. The second condition, we have 2 is equal to minus 1, that's also false. So it goes to the last one. We can change the first one and we can say, what if 1 is equal to 1? And now we can go back to the terminal. We can compile again and run it again, and now we can see the first condition is true. Next, we'll look at another type of conditional statement called the switch statement. The switch statement causes control to be transferred to one of several different statements, depending on what the value of an expression which has to be evaluated, and it must evaluate to an integer type. Here you can see the expression is enclosed in parentheses. The statements within the switch may be labeled with one or more cases, which consist of the keywords case followed by a constant expression and then a colon. Typically, each of the case values uses break to exit the switch, otherwise the following cases are evaluated. So it's important to note here, first we begin with the switch keyword followed by the parentheses with the logical expression, or with the expression that should evaluate to an integer. Then you have an open and closed curly braces, and within this you must list all the different cases, and you can also optionally include a default case, but you should have no other code besides these cases within the curly braces. Each case has a keyword case followed by an integer label followed by a colon, and then the statements can follow that case. You can have multiple lines of statements after each case. It's normal to use the break statement between each case. So in this example, if the expression evaluated to label 1, both the statements in statement 1 and the statements in statement 2 would be executed because there's no break in the case for label 1. If none of the labels are found among all the different labels in the switch statement, then the expression moves to the default and evaluates statement 3. Next, we'll look at an example of the switch conditional statement. Here we have an example where we use switch with a typedef enumeration for the days of the week. Here you can see the typedef enumeration with Monday, Tuesday, Wednesday, Thursday, and Friday as weekdays. And here we can see we initialize today as a weekday type as true. Now we use a switch statement on today, and we make each case Monday, and we printf today it's Monday, and then we break. Case Tuesday, printf it's Tuesday, and break. Case Wednesday, printf it's Wednesday, and break. And then by default, it's time to party on the weekend, I guess. So in this case, we've assigned today to be equal to Tuesday. So the statement switches to case Tuesday and prints it's Tuesday, and that's what you can see here as the result. If we make some small changes to the code, we can see how it reacts differently. First, we'll make the switch on the integer 1 instead of on Tuesday. Next, we'll put a comment where this break statement was on Tuesday and another comment where this break statement was on Wednesday. If we run the code again, we'll see that it prints out it's Tuesday, it's Wednesday, time to party. And the reason why it does this is because the value for Monday is 0, so the value Tuesday is 1, and Wednesday is 2, and so on. So it first moves to case Tuesday and prints it's Tuesday. But now, because we've commented the break statement, it moves on to Wednesday and it moves on to the default, and it prints all 3. So you can see the need to have these break statements. The while statement is an iteration statement and one of the most useful statements for iterating in C. In the while statement, we have a substatement, which appears here, that is executed repeatedly as long as the value in the expression remains non-zero or equivalent to true. All side effects from the expression occur during each iteration. So we can look very simply at a very simple example of a while loop. Here we have a counter variable integer ii, which is equal to 0, and we have a while statement that says in parentheses, so here's the expression we evaluate every time, ii is less than 10. And in the statement that gets executed while that is true, we have a printf %d, and then we have ii++. And in C, ++ means add 1 to the previous value of I. So now we can look and try and imagine what the output of this code produces. So since we know that integer is the counter variable is initialized to 0, in the first round of the iteration, we see ii is less than 10, and so we execute the statement, and so it says printf the value of ii, so it prints 0. And then it says ii++, so this adds 1 to ii. So now we go back to the while statement and look at the expression again, and ii is now 1, but it's still less than 10, and so we execute the printf statement again, and we keep doing this until we get a value of 9. Next, we'll look at the do-while iteration statement. The do-while statement is quite similar to the while statement. The main difference is being the placement of the statement and the expression that you must evaluate. In the while statement, the condition is set at the beginning of the loop, and it makes it possible to never enter the loop. But in the do-while expression, you can see we begin with a statement, and then we have the condition afterwards. So you always have to execute at least one statement. Otherwise, they function quite similarly. Here we can look at an example of a do-while statement where we have an integer, a counter variable, kk, which is initialized to 0, and then we do a printf, and then %deep, printing out the value of that counter variable, and then we have the condition afterwards, where the condition is looking if kk is less than 10. It's interesting to note here, this time we have plus plus kk instead of kk plus plus like we had with the while loop. Plus plus kk increments kk before using its current value. So what happens when we do this loop is actually we begin with a kk value of 0, we print it here, and then kk becomes 1 before we evaluate the condition. So it doesn't really matter now, but when we get to the last iteration of the loop, when kk is now equal to 9, we print out kk is equal to 9, and then we increment it before we check the condition. And so that makes it so we don't go back for a 10th iteration on the loop. And so you can see this is what the output will look like. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The last type of iteration statement, a for loop, is similar to the do while and the while, except that a for loop allows you more flexibility. It allows you to initiate a counter variable, check a condition, and increment your counter all in a single line. Typically, a for statement the syntax looks like this. We begin with expression 1, where we initialize the loop variable, and then we place expression 2, where we have the conditional expression. Here, this is the statement that keeps that has to be true as long as the loop is running. And lastly, we have an expression 3, which is a modifier that's typically used to increment variables. So, like before, we have an example where we want to increment a counter variable, this time jj. So we declare integer jj, and then inside the for loop, we give it an initial value of 0, and here's the conditional statement while it's less than 10, and then we have the increment, the modifier, an incrementer, where we have jj++, and then inside of the statement we execute a printf with the value of jj. So once again, the output here, just like in the previous examples, is 0 through 9. So it's important to pay attention to the syntax. You need the semicolons between each of these three statements in the for statement in order for it to evaluate properly. Lastly, we have a few other statements which can be used for flow control within the other flow control statements, like the switch or the for or the while loops. First, we have break, which allows you to exit from a loop or a switch. Next, you have continue, which lets you continue or to skip one iteration of the loop. Finally, you have goto, which skips to the labeled identifier given this type of syntax, goto identifier. In general, goto statements are bad practice in C, and we try to avoid them, and people generally do not think it's good code if you have a goto statement in it. So here I have a rather convoluted example of a while statement with a few conditional if statements inside of it, along with these continue or break, continue, and go statements. So let's try and walk through this example. First, we declare an integer I and give it a value of 0. And next, we start a while loop that goes from while I is less than 10. Now we have a series of if conditional statements. The first one checking to see if I is equal to 1, then I is equal to 2, then I is equal to 3, and then if I is greater than 4. Finally, we have a printf statement. So when we begin with I is equal to 0, we enter the while loop and we see that it's not equal to 1, 2, or 3, and it's not greater than 4. So we print out a 0, and then we add 1, we increment the counter variable so that it's now 1. We head back to the top of the while loop, and now we can see that we've reached the first if statement, and that is true. So now we print out the value of the counter variable, which is currently 1. So we print out 1, and then we increment it, and then we continue. So this means we go back to the next iteration of the loop, and now I has the value of 2. So we skip the first condition, and now we go to this if statement, and here we see I is 2. We increment I, so it's now 3, but we don't print, and we hit continue, so we never hit this print statement here, and we go back up to the while loop. So now we have a missing 2 in our output, and now we're back up at the while statement with I having a value of 3, and we can see down here I is not equal to 1, I is not equal to 2, and then we have I equals 3, and now we have a goto statement which says go to my label. So the code moves up to the my label here, and then it executes a printf statement where I is equal to 3. It adds 1, so I is equal to 4 now, and then we hit a continue statement which brings us back up to the while loop. Now I is equal to 4, and so it's not equal to 1, it's not equal to 2, and it's not equal to 3. And now I is not greater than 4, so we print the value of I down at the bottom. So now we have we have a value of 4 printed to the screen, and we increment I once more. So now we go back to the top of the while loop, and I is not equal to 1, it's not equal to 2, it's not equal to 3, and now it's greater than 4. And now so we hit the break statement, and this exits us from the loop or the switch, so we don't print any more values, and this snippet of code is finished. So we can see through this convoluted example that a break statement can exit you from a loop or a switch. A continue statement can let you continue on within the loop or switch, ignoring the rest of the statements below it. And a goto statement can let you move within the code to a labeled new location in the code. This concludes our lecture on flow control and loops. Thank you for watching.